Hello guys and welcome to Data Structures and Algorithms. So in this video, ang i-discuss natin ay yung tinatawag natin na data structure. So let's start with data or datum in singular. A data is a collection of unprocessed items. It can be text, numbers, images, audio, or video. A data could also be a raw material. It can be anything that we entered into a computer from different input devices in order to generate what we call information. And a data could also be a representation of facts, concepts, or instruction, which is suitable for communication, interpretation, or processing by either human or an electronic machine. When it comes to data, the main problem is finding the data itself. Imagine yourself in this particular situation. Okay? Ayan ka, nasa desk mo na hindi mo na alam kung paano siya ayusin. Magkakasama na yung file mo. Or on the right side, makikita mo dito yung image na sa stack of paper na yan, meron kang kailangang hanapin na isang document. Okay? So, the problem is not only finding the data itself, pero yung time and then yung effort in order to find that data, kailangan rin nating i-consider. To solve that particular problem, mayroon tayong tinatawag na data structure. A data structure is a systematic way to organize the data in order to use it efficiently. Given yung example natin kanina, okay, we have a particular way to organize our data, yung mga hard copy documents natin. Okay, meron tayong tinatawag na file cabinet in which each cabinet nilalagay natin yung document sa specific folder. Na yung folder meron siyang label or tag para later on madali nating mahanap. In your computer system, meron naman tayong tinatawag na ito, yung ating directory or folder in which yung mga pare-parehas na file or related na file magkakasama sa isang directory or subdirectory. And then, lastly, may mga tinatawag tayong file types na nakakatulong para una, mapadali yung paghahanap natin ng particular data. And then, pati yung pag-combine, okay, ng mga specific files natin na related or pare-parehas. So, we have the foundation terms when it comes to data structure. May tinatawag tayong interface and implementation. When we say interface, it represents the set of operations that a data structure supports. It also provides the list of supported operation and type of parameters they can accept. While implementation provides the internal representation of data structure. It provides the definition of the algorithms used in the operations of that data structure. To simplify, let's have the particular example. Meron tayong credit card, okay? A credit card, pwede mo yung gamitin para bumili ng any item regardless kung ano yung tawag dito, kung ano yung accepted na bill. Okay? For example, meron kasing dollar bill, may pounds, we have the Philippine peso. Okay? Para hindi ka na mahirapan later on sa pagbili kasi baka hindi sila tumatanggap ng dollars, hindi sila tumatanggap ng Philippine peso, we have what we call the credit card. The credit card, that is equivalent to what we call the interface. Now, the implementation is yung tinatawag natin na bank account. Kasi para magamit mo yung credit card, you need a valid bank account na merong laman. Okay? So, ganun lang kasimple yung difference when it comes to interface and implementation. The interface just defines what an object can do but won't actually do it, while the implementation carries out the instructions defined in the interface. Next, we have the categories of data structure. So, we have two. We have the linear and non-linear. Okay? Given the particular image, makikita natin na in a linear, okay, from the word itself, linear, the elements or the values form a sequence. And each values have unique successor or predecessor. The difference in non-linear, okay, kabaligtaran lang siya, They have, or the values do not form any sequence, and they do not have unique successor or predecessor. Ang example natin ng linear, we have arrays, stack, quiz, and linked list, while the non-linear, we have the trees and graph, which later on itatakal natin in the following or in the coming topics. Next, we have the characteristic of data structure. First and foremost is the correctness. So the data structure implementation should implement its interface correctly. So sabi kanina, ang interface, it defines kasi ano yung mga possible operations lang na pwede sa kanya. Therefore, kailangan upon implementation, masatisfy lang that particular condition. Next, we have the time complexity. When we say time complexity, the running time or yung execution time ng operations of data structure must be as small as possible. Ibig sabihin, once na in-implement natin, kailangan yung pinaka-minimal na time para mag-execute yung program, okay, or yung algorithm, kailangan ma-meet natin yon. And lastly, we have what we call the space complexity. When we say space, in data structure, we're pertaining to what we call the memory. Okay, ito yung resources na ginagamit natin sa ating machine or sa computer. So, the space complexity, or in space complexity, the memory usage of the data structure operation should be as little as possible. Sabihin, yung allocated resources na magagamit mo para doon sa yung algorithm, kailangan as much as possible, unti lang yung magamit natin na memory. Okay? Next, the need for data structure. Bakit nga ba kailangan yung data structure? Okay, bukod doon sa binigay kong example kanina. So, nowadays, as applications are getting complex and data rich, so there are three common problems that we face. The first one, okay, katulad kanina, the data search. Another example tayo in the data search, consider a book. Okay, meron kang libro. And that particular book, wala siyang table of contents tsaka glossary. Ibig sabihin, hindi mo alam kung saan particular page makikita yung certain topic. So each time na may hahanapin kang topic, kailangan mo mag-start dun sa umpisa ng book, sa first page until sa last page. So paulit-ulit kang nagse-search ng ganon, and habang lumalaki or habang dumadami yung pages and then the data, mas bumabagal ngayon yung pagse-search mo ng particular topic or info. Now, another thing is the processor speed. Okay, ayan po, yung processor, yan yung tinatawag natin na CPU or Central Processing Unit. Okay, don't be confused yung malaking box when you're using desktop computers, that is called system unit. So, ito yung CPU, yung brain ng computer natin. Pwede nating sabihin na nowadays, napakabilis na ng mga processor natin. From before na meron lang dual core, okay, naging i3, i5, i7, we have the Ryzen sa AMD. Although bumibilis siya, lumalaki din kasi yung mga data and mga kailangan niyang i-process. So, unlike before, mabagal lang ang processor. Bakit? Kasi limited lang yung pwede niyang gawin. Pwede lang siyang pwede lang ang computer natin for office works like MS Office, Word, Excel, PowerPoint. Unlike today, na mabilis nga yung processor, pero yung requirement na kailangan dun sa computer natin for high-definition gaming, video editing, nagbabaris pa rin doon. Kaya hindi natin masabi na porket mabilis na yung processor speed, wala na tayong magiging problema when it comes to the data. Another thing is the multiple requests. Okay, imagine ngayon na lahat na nakarely sa internet. Okay? Meron kang dina-download na music or image or video. So, can you imagine, okay, since internet is available almost all around the world, ilan kayo na user na sabay-sabay nag-access ng file, nagda-download, nag-view, or anything? So, yun yung isa pang kino-consider when it comes to a data or data structure. So, to solve the above-mentioned problems, okay, Andyan na nga yung tinatawag natin na data structure in which the data can be organized in a way that all items may not be required to be searched and the required data can be searched almost instantly. Next tayo is what we call the data type. So, familiar na tayo sa data type kasi in any programming topics, hindi nawawala yung data type. From the word itself, data type is a way to classify the various types of data, which determines the values that can be used and the type of operations that can be performed. So, we have two data types. Meron tayong built-in data types, meron tayong derived data types. Familiar na tayo sa built-in data types. So, these data types for which a language has built-in support. Kagaya nitong image na to. We have the 4, 2.5a, and hello. So, ito na yung mga common na data types na alam natin. We have the 4 as the integer, yung my point, that is double or float. And then a single letter defines character. And then we have the hello, which is string. We also have the boolean. So, kaya siya tinawag na built-in kasi kahit anong programming language yan, meron na po yan. Okay? Yung derived data type naman, these data types are normally built by combination of the primary or built-in data types and then yung operations na meron sila. Kagaya ng array, linked list, stack, and queue. So in this subject, data structures and algorithms, dito tayo magfo-focus doon sa mga tinatawag natin na derived data types. Later on, malalaman nyo paano nangyari na na-combine yung built-in data types and then yung operations na meron sila. Last, we have the basic operations. So any data type, any derived data types, dito lang iikot yung discussion natin. Okay? First one is the traversing. When we say traversing, this is accessing or printing all the values in our data types, derived data types, kagaya ng array. Searching, familiar na dyan, finding a particular value. The insertion, which is adding a specific value. The deletion is removing a certain value. Sorting, arranging those values in a particular order, kagaya ng ascending or descending. And lastly, we have the merging or combining of values. So before we end, okay, we have the following references. Syempre, yung sa tutorials point. Okay, for our data structure content. And then dito sa baba, nandito yung mga URL na ginamit ko para dun sa mga images na ginamit natin. And same with the PowerPoint template. Okay, so with that, that's all for data structures and algorithms in respect to or with respect to what we call the data structures definition. So, thank you and see you on the next topic.